Hello everyone, welcome to my YouTube channel. My name is Evidence, and in today's video I am going to show you how to build a Gaussian Naive based classifier from scratch. So just so you know, I wrote a blog post about this and it's right here. And in this blog post I basically cover everything I'm going to cover in the video today. So if you prefer to look at the blog post instead, you can go to evidencen.com/gmb classifier. So yeah, I did write a blog post about how to build a Gaussian naive based classifier from scratch. And also in today's video, I am going to reference Wikipedia page a lot. So the Wikipedia page I'm going to be using is also right here. And you can find today's code and every other resource I have at machinelearningeducation.com. So if you go to machinelearningeducation.com/free, you'll be able to join my free data science resources community. And basically in here, I provide something like code like this one and other resources I use in my videos and blog. I do a lot of videos and I also do a lot of blogs, and since I have so many different resources, I figured it would be easier to put all of it under one platform. So machinelearningeducation.com/free, and you'll be able to join my free data science resources, and here I have other resources that I use in my blogs and videos. And also this code is in my GitHub. I put a lot of my code in GitHub, but one of the reasons why I don't put everything on GitHub is because it can get confusing trying to find the resource or the tutorial code for a particular video. So even though this is on GitHub, it's also right here inside my free data science resources page. And this is the main machinelearningeducation.com. Here is where you get machinelearningeducation.com/free, where I have different things. So with that being said, let's start. The first thing I want to do is make sure you fully understand Gaussian naive base. So let's go to Wikipedia here. So if you go to the Wikipedia page for naive based classifier, you can see that there are different types of naive based classifiers. There's Gaussian naive based, which is what we'll be talking about today. And then there is this one and semi-supervised, and I think I missed one, multinomial. Yeah, multinomial naive based. And if you scroll down a little bit all the way to the end, it gives you an example of how a Gaussian naive based could possibly be used. So in today's video, as I'm building this algorithm, I'm going to use the example from Wikipedia, because if I use the same sample data set that they used here, I should get the same answer as them, and it will just make it easier, because if I'm writing the algorithm right, then I should get the same answer as them. But if my algorithm is wrong, then my answer should differ. So as we build this algorithm, we are going to use Wikipedia as our fact checker. Now let me actually explain to you what Gaussian naive based classifier is. So if I just start building the algorithm, it might confuse you a little bit, like, why are we doing this? Why does this matter? So to begin, before we get to the code, I'm going to explain to you Gaussian naive based classifier using this example here from Wikipedia. So this right here is a Gaussian naive based equation. This is what we are going to be building today. And this can also be found here on Wikipedia. So it's the same equation right here. So basically, using this equation using this example to explain this equation, well, let's just start by looking at the equation alone. As you can see right here, this is saying what's the probability of the given sample given these variables. And here it's saying 1 over the square root of 2 times pi. So pi is a constant. And this symbol right here means the variance. And then you have the natural log to v. This v looking symbol right here is a value. And this symbol is called mu. And this means the mean squared over 2 times the variance. All right. Assuming we have this sample data set right here and we are trying to calculate probabilities, right? And then you also have this sample data here and you're trying to find out, is this sample data male or female? I'm going to explain this right here. I'm going to explain this equation using the example. So here we have height, weight, and foot. All right. And this V right here represents value. And that value is going to be something like height 6, weight 130, and foot 8. So we have to calculate the height, weight, and foot for both male and female. We have to calculate the mean and the variance. So we start with our sample here and then we have this. So basically the first thing we do is we calculate the mean for height male and calculate the mean for height female. All right. So we calculate the mean for height male, calculate the mean for height female, and then we'll do the same thing for variance. We calculate the variance for height male, the variance for height female. Then we have to calculate the mean for weight, male and female, calculate the variance for weight, male and female. And also, male and female is the two classes that we have. We can have more than two classes, but in this situation, we are just dealing with two classes. So basically, the idea is that for each feature that you have, you need to calculate the mean of that feature for each class, and then the variance of that feature for each class. So that's one of the first calculations we are going to do. So we are going to write code that will be able to do this for us automatically. And then we also need to calculate the prior. So prior is basically our prior belief. And basically prior is calculated by doing 1 divided by number of classes. So if you had 3 classes, it'd be like 1 divided by 3, which is 0.33. If you had 2 classes, it'd be like 1 divided by 2, which is 0.5. So basically, prior is just saying what is your prior prediction? What is your prior predicted probability? So without doing any math or any calculations, you predict that the probability of this sample being male is 50% and the probability of this sample being female is 50%. So that's what prior is, and we're going to calculate that with code also. So now they talk about posterior male and posterior female. You can read more about that, but I'm going to jump ahead and actually get to the equation. So this is where we put the equation into use to calculate probability. All right. So basically in this situation, we are saying we are using this sample data. So here we have height 6. So basically this is our unknown. We are trying to predict we are trying to say what is the probability of this sample being male or female. So we are saying height 6, weight 130, and foot size 8. And then we take that information and we plug it into the equation. All right. So here we're basically saying the probability of the sample being the probability of height and male is going to be this. So basically this 6 is from the sample data, and then we have the variance for height male, and then here we plug in the variance for height male, and here we plug in the mean for height male. And here you can see that the mean is 5.855, and then the variance is 3.5 times 10 to the negative 2. And this information right here, of course, is pulled from this table. Mean for height 5.855, and then variance is 3.5 times 10 to the negative 2, and the number 6 is coming from this. And basically you take all those information that you calculated and you plug it into this equation. So you take the mean that you calculated, the variance you calculated, and the value in question, which is 6, and plug it into this equation, and this is the probability of height male, the probability of this sample being male given the height, and then this is the probability of the sample being male given the weight, probability of the sample being male given the foot size. So now the next thing you calculate is the posterior numerator, okay? And then the posterior numerator is the product of this. So you take this right here and this and this and get the product of them, to multiply them together. And then the prior for female is also 0.5, and then you also calculate probability of the sample being female given the height, female weight, female and foot size, and again you calculate their product, and this is the probability that you get right here. So basically you multiply each of these individual probabilities with the prior probability, and then you have the final probability right here. And as you can see right here, the probability of female is higher than the probability of male. So basically we predict that the sample that we are given belongs to a female sample. So that's kind of like the basics of translating this Gaussian naive Bayes equation into actual probability calculation. And I hope this kind of give you some kind of proper background about what we are going to be building. So with that being said, let's go ahead and actually start coding. So basically here I'm just going to use the height, the information from Wikipedia. So basically this sample data right here is what I'm going to be using from Wikipedia. So this right here is from this example. So I have the height, the weight, and the foot, and then I converted male to 0 and female to 1. So basically we have two classes, and our class is our y value, and basically in this situation I just assign 0 to male and 1 to female. And of course this is an example of what our x values look like. And this is a sample of our y values. So the first thing we are going to do is to calculate the mean and variance. Now I am going to do functional programs. So I'm going to do this line by line, and then after everything is done I'm going to put it in a class. And I found like the easiest way to calculate the mean and variance by group is to use pandas group by, because we want to calculate the mean for each class, right? We have two classes. We have our male class and our female class. We want to calculate the mean for our male classes and also calculate the variance for our male classes. So just to make my life easy, I'm gonna say x equal to x values. All right, and I, quickly I'm going to show you how the group by function works. So I can do x dot group by y by equal to y dot mean. So basically here it's giving us like the height. So this is here is the mean information. So we have the height for male, and then we have the weight for male, foot for male. This is the mean, and then height for female, weight for female, and foot size for female. And just to make sure we are accurate, we're going to check the Wikipedia page. So Wikipedia says here we have height is 5.8 and 5.4. 5.8 and 5.4. So we know that the answer we are getting here is correct. And also we can get the variance using pandas group by. And then here we have like the variance for height is 0.035, which translates to 3.5 times 10 to the negative 2. And if we go back here, we can see the variance is also 3.5 times 10 to the negative 2, 9.7 for female, 9.7 for female. So here we know for a fact that we can get the mean and the variance of our futures by each class using pandas group by function. So now let's just use this to, let's say, build what I call our fit function. And in this case, let's just create a function. So in this case, we are just creating something for that will give us the mean and the variance. So now we can do return mean comma variance. And let's go ahead and execute this. And now let's just call this, let's say, mean comma variance is equal to, and for x we pass in our x and then y. So x here is the x value we defined earlier, and y here is the pandas series we defined earlier. All right, and let's go ahead and execute this. And now let's type in mean and variance. As you can see, actually we can do it line by line, we can do it individually. As you can see, it gives us the same information that we had above. And let's do variance. It gives us the same information we have above. So we just created a small function for calculating the mean and variance for each future by class. So that's kind of like the first step, being able to calculate the mean and variance for each future by class. Okay, so now that we have the mean and the variance of each future by class, the next challenge we're going to be dealing with is combining them together, okay? Because when we write our final function, we want to have the height. When we plug all of this into the equation, we want to plug the height for male, variance for male into the same equation. And it will make it a whole lot easier if we had this and this on the same line. So the next step here is combining the mean and variance for each future. And once I do this, it will make a whole lot more sense. So for us to be able to do this, we need to convert this into an array. So to do that, we do, let's just say m is equal to np.array, and let's say mean. Basically this is converting what we have here into an array. And we can just do something like V and get a preview. So basically the same information we have above, but in an array format. And having it in an array format just makes it easier to loop through it. So what I'm doing here is just looping through the mean and variance to pull out individual values for each feature. And I'll show you what this looks like here in a minute. So to do this, we just do for I in range length of m. So basically we are saying that length of m, for example, is 2. So we are basically saying we want to do this 2 times. If length of m was like 5, for example, this code will run 5 times. But in this case, we just want it to run twice. And then we say m row is equal to m at position I, which is like the first thing, and then v row is equal to v at position I. So enumerate is a way to get the index and the value. So basically, when you have something like a list and you want to pull out the index of that item as well as the item, use enumerate. Enumerate allows you to put the index. The first item is always the index, and then the second item is the value. So I can call this index and then value. And this right here represents the first row, okay, and this represents the first row of variance. And what not just for what this the first row, then next row of mean. So basically the first I represents the first row, second I represents the second row. So it will run this 2 times. The first time it will take the first row, second time it will take the second row. So let's just say in this case the mean is equal to the value and the variance is equal to v row at position index. So, and in this case I'm just gonna print it out I'm just gonna print this out because it will make it a whole lot easier understand what's going on. In this case we want to print the mean, and then we want to print variance, and here let's print variance, and let's go ahead and run through this. So this is what we get here, right? So we have, so the first 3 represent the male, and then the second 3 represent female class. So what we have here is we've done pairing up, okay? So this is the mean for male height, and this is the variance for male height. Mean for weight, for male weight, variance for male weight in a foot size, and then this is for female, and this is the mean and the variance and weight, and then this is foot size. So basically with this line of code right here, I was able to go through these 2 data frames and just pull out the information. All right, and if I do this right here, it will help you maybe understand the code. Like if you are struggling to understand this here, let me see if I can explain it to you. So basically we are saying for each item in the length of m is 2, 1, 2. Okay, and then we are saying m row is equal to m at the first index. Okay, so basically we are saying m row is equal to the first row here, and then we are saying that v row is equal to the first row right here. All right, and then we are saying for index value and enumerate m row. So we're basically saying that m row is this right here, and we are saying for the first item, so the index right here is 0, and this is index 0, index 1, index 2. Okay, we are saying that the mean is this value right here, and the variance is whatever is located at the corresponding index. So this is the variance right here. So you're saying that the mean is that this right here is the mean, and this is located at index 0. So the variance is whatever is at 0, index 0. All right, and then we repeat that over and over again. Okay, so now it's gonna go through and be like, okay, now the mean is 176.25, and then this is located at index 1 of the first row. So the corresponding variance is 1.229, which is located at index 1 of the first row. And then after going through each value in this row, it will go on to the next row, which is this right here. It will repeat the same process for the second row. And we know that the first row represents male. So the first 3 items printed is male. And then we know that the second row represents female. So the second 3 items printed represents female class. So basically why I did this is to take the information right here and the information right here and combine them together side by side. So basically I'm going to repeat this process again, but this time I'm going to put, instead of printing it out, I'm going to put it in a list that we're going to use. So let's call this list equal to mean variance, and let's basically copy this. And then here we'll do mean variance dot append. We want to append a list, and this list is going to contain the mean and the variance. And here let's go ahead and execute this code, and let's type in mean variance to kind of like see what it look like. So right here we have a list of lists, same information as this, but now it's stored in a variable, mean variance. And here this, of course, the first 3 items on the list represent male class. Second 3 items on the list represent female class. So the next step is splitting our list into the various classes. Okay, and to do that we first have to turn our list of mean and variance combo into an array. And to do that is very simple. Let's just call it main variance 2, and let's say np.array mean variance. And of course we can do mean variance too for you to see what it looks like. As you can see, it's basically the exact same thing, but now it's an array. The reason why we are turning it into an array is because we are going to split it up by class, and the thing we are going to be using to split it up by class is requires the inputs to be in an array, and you'll see that here in a minute. So let's start by calculating the number of classes that we have, because that will determine how we split this, right? So basically here what I'm saying is that numpy has a unique function, and basically we passed in y value. It's going to tell us how many items is in our y value. And if I just do it without the length thing, it will make it easier, because I really want you to understand what's going on. So as you can see, it tells us we have 0 and 1. Those are the two unique items in n class. Now if we want to just get the length of this, it will tell us how many unique items, and we already know it's 2, but still, yeah. So we have 2 unique items in this class. And to separate mean variance by class, we use a numpy v-split. Alright, so let's just call it s is equal to np.v-split, and then in this situation we need to pass in our distance. So this is what I'm talking about. This right here has to be an array. If you just pass in a regular list like this, it might throw an error. It needs to be in array format. I think I tried that before, it threw an error. That's why I put it in an array. And then it's going to ask us how many sections to split it into. We want to split it depending on the number of classes. Now you might be thinking, why don't I just put 2 here? Well, guess what? If at the end of this, I am going to put this into a function, right? And the number of classes might change, based on the data set. So we want to use n classes right here. And let's type in s right here and see. So this is what we get. We get 2 arrays with our v-split. The first array represents male class, and the second array represents female class. Alright, so if you go back here, you can see this is our sample data. Right here, 6, 130, and 8. So we are going to just call it sample. It's equal to just a list. We are going to call it a list. So 6, 130, and 8. And this is our sample data. Sample data that we are trying to predict. Now what I'm going to do is I am going to combine this value, this sample data, with our mean and variance, because once we actually start plugging stuff into the equation, it will make more sense. It will make more sense why we need to combine things like this. So basically what we are going to is combine sample data with mean and variance for each class to simplify equation. All right, so basically I'm going to build this, and again it may not make much sense now, but just stay with me here. Let me finish writing the code and print the output so you can see what it looks like, and it will make a whole lot more sense. So basically I'm going to say for I in range number of classes. So we know number of class is 2, right? We saw that earlier. And we are going to say that class 1 is equal to s at position I. So basically we are saying that this is first class. So we are saying, s right here is our data split, right? So we are saying that the first class is this, and then the second class is this. So it's going to run this algorithm twice. The first time it's going to run this algorithm through the first class with the first array, and then the second time it will run it through this. And this is another reason why I use number of classes right here, right? Because if we had like 10 of this, it's going to run this 10 times. And then we do for I in range length of class 1. So we know that class 1 here is the first array, all right, and the length of class 1 is 3. We have 1, 2, 3. So it's going to run this outer for loop twice because our number of class is 2. It's going to run this inner for loop 3 times because the length of each array is 3. Okay. So basically we're saying first row kind of slash value in class 1. And now we are going to pull out the variance. So basically this right here is this mean, and we are saying like the variance is this, all right, and this is position 1, and let's call this variance. Then we are saying that x values is equal to our sample at position I, at the first position. And I'm just gonna print this right here to make it easier for you to understand what's going on. And let me copy and paste this because I don't want to retype it. And let me go ahead and execute this. All right, so this is what we get right here. Okay, so what we have here is the height for male, mean, the variance for male height, and then we have the sample for height. This is the sample height that we got. Okay, and then we have the weight and mean and variance for male, and then we have the sample weight that we got, and this is the sample foot size that we got, the variance and mean for male foot size, and then this last 3 belongs to female. So basically what I did was here take the mean, the variance, and pair it up with the sample that we get. And putting stuff out in a list like this will make it so much easier to loop through it and plug it into the equation, like the Gaussian Naive based equation. So basically everything I'm doing so far is, yes, doing the mean and variance calculation, but also formatting our data in such a way that when we go to plug it into an equation, we'll be able to plug everything in easily without having to do hard coding anything. Because we want to build this algorithm in such a way that it's adaptable to other data that we might have in the future. So To explain this code a little bit here, so basically we are saying that class 1 is like the first array class, okay, and then we are saying for each item in the length of class 1, so length of class 1 is 3, and then so we are saying that each item is going to be, item number 1 is going to be this, item number 2 is going to be this, item number 3 is going to be this. So this inner for loop is going to run 3 times and the outer for loop is going to run 2 times because n class is 2, length of class 1 is 3. So we are saying that the mean for in class 1 is the first item at location 0, and then the variance is the first row at location 1. And the first time it runs through this, it's going to pull this out and pull this out. And then we are basically saying that the corresponding x value, that the x value that correspond, like this x sample, should I call it x sample to make it easier to understand? So basically we are saying that the x sample that correspond to this mean and variance is the first item, okay, and then the second time we run this, we are going to pull out this mean and then this variance, and we're saying that the x sample that correspond to this mean and variance is the second item, and then it's going to run this the third time. That's how you get this 6138 from the inner for loop, and then once the inner for loop finishes, it goes back out and runs the outer for loop again. And when the outer for loop runs, that's how you do this again. And now it's doing it for the second class, which represents female. Again, all of this is really getting our data ready. So now that you see what this looks like, let's go ahead and actually build the equation. So building the equation. All right, and I'm going to copy this right here. So basically this is a Gaussian naive based equation. So building the equation using code. All right, and after building the equation, then we are going to do the magic of combining this information with the equation to get our probabilities. All right, the fun part is coming up, I promise. So let's call this function GNB, and here we are going to provide our x value, we are going to provide the x mean, and we are going to provide the x variable. All right, in order for us, I call it GNB stands for Gaussian naive base, so I'm going to call this GNB equal Gaussian naive base. So first we would say the variance of x value in question, and this is not necessary, but I just found it easier to make sure things are explicitly defined. And let's say mean of the x value in question, we are going to call it just mean, why not, it's equal to x mean. And then if you look at this equation, we have this e stands for natural log, so we are going to define natural log, okay. So this is natural log, so e is equal to np.e. So numpy has a built-in natural log just got np.a. So natural log, if you do let's see, yeah, so this is natural log, right? So natural log is just a constant. It's already defined for you. You don't have to like reinvent the wheel, basically. So this is our natural log right here, which is this e. And then we need to define our pi. And again, we are just going to say pi, don't like having too much spacing. Pi is equal to np dot pi. And again, pi is a constant. Okay. So we are going to break this equation down. First, we are going to build the first part of the equation, and then we are going to build the second part of the equation. All right. So the first part of the equation is just 1 divided by the square root of 2 times pi times the variance. And to do that, so let's just define first part of the equation. And we are going to do equation 1 is equal to 1 divided, and let's put this in parentheses for clarification. We are going to do, actually let's do, so if you look right here, it says 2 times pi times variance. So let's go ahead and do that. Let's say 2 times 2 times pi times x times variance. All right, and as you can see, this equation has a square root around it. So that's exactly what we are going to do. So we are going to parentheses this again, and we are going to do np dot square root. Again, numpy already has a built-in square root function. So basically what we are doing is numpy square root of this whole thing right here, and all of this is divided by 1. So that's basically the first part of the equation right there. So let's implement second part of the equation. All right, so if you look right here, this is the second part of the equation, and all of this is raised to the natural log. And let's just start by looking at the denominator right here. So the denominator is 2 times the variance, and let's just define that. So let's say denominator is equal to 2 times variance. And now let's do numerator calculation. As you can see right here, actually I can move this down to make it easier so I don't have to keep scrolling back up. As you can see right here, the numerator part of the equation is the x value in question minus the mean corresponding to that particular x value squared. All right, to implement that is very simple. We'll just call it numerator, and then basically says equal to the x value, right? I called it x value minus the mean times 2. So basically to raise stuff to the power of 2, you use this symbol right here. Now let's do the exponent. All right, so we have the first part of the equation, we have the numerator, we have the denominator. So now let's put all of this together using the exponent. All right, so in here let's do expo is equal to np dot So don't get confused by this exp right here. np.exp is the same thing as this one. So to calculate the exponent, we do np.exp, and then we do negative. Then we put it in parentheses again. We say the numerator divided by the denominator. Alright, so basically we are calculating this part right here. So we've calculated the numerator right here. Where's that? Right here. And then we calculated the denominator, and then we are doing that the exponent. We are doing the natural log of this right here with this calculation. And now to put everything together to create a probability equation, we have to say we say probability is equal to equation 1 that we wrote earlier times exponent. This is what we call it. So basically we are saying that this first equation times the second equation, and we know that the first equation is this right here, and then the second equation. And basically with our function we just return probability. So basically with this function right here, we just put this equation into code, and I did this line by line to kind of make it easier for you to follow and kind of understand which part of the code corresponds to which part of the equation. So now that we have all the pieces in place, we can go ahead and start calculating our probabilities, right? We have the mean, the variance for each feature. We have paired them up in such a way that it's easier to work with. We've built our probability equation, and now it's time to start calculating probabilities. So now we are going to calculate the probability for each class using sample data. And again, I'm going to paste the sample data here just to make it easier for you to remember the sample data that you're trying to predict. So that's sample data we are trying to predict. And I'm just gonna create this as an empty list, and of course I'm going to write the code, and after the code is done I'll take time to kind of explain what's going on. So we are basically doing for I in range number of classes. So we know that number of classes 2. So if we had 5 classes, we'll do n class. That n class represents 5. And we are going to say our first class. So basically similar to what we did earlier. So you've seen this code before when I showed you this right here. You've seen this code before. So what we are doing now is very similar to this. So actually I'm just gonna go ahead and copy this because it's pretty much the exact same thing with minor changes. And the reason why I did this up here is kind of show you the end result before we to show you what our list looks like before we do our probability calculations. All right, so I'm just gonna remove this line of code right here because we don't need it anymore. And then now we are going to now calculate the probability for each class. And I put in all these comments just to make it easier for you to remember what's going on. And if you want to go back through this code again, I don't want you to get confused like, oh, what are we doing? What were we doing? So, okay. So now we need to put in our X value, and our X value here is the X sample. And then our X mean is this right here. And then our variance is this right here. And also look like I made a mistake here. So X var, make sure this is correct. I don't want any mistakes. All right, so basically right here we are putting the probability equation that we wrote above is basically this, and we are putting it to the test now to calculate our probabilities. Let's go ahead and run this code, and boom, just like that, these are the probabilities that we have. Okay, so now the way I have this written is just printing it out, but I want to store these probabilities in a variable, so that's why I created this empty list. So instead of print, I'm gonna do probability.append, and .append, and I want this to be in a list format. So I run this, and now let's look at our probabilities. As you can see, the exact same thing I just showed you, but now in a list format. All right, so we have our probabilities, and then this is our probability calculations. And as you can see, the first 3 represent male probabilities, and then the second 3 represent female probabilities. And I already explained this to you earlier. So basically, the code above is the same thing as this code, but now I'm taking this value and plugging it in for X mean, taking this value, plugging it in for X variance, and then taking this value and plugging it in for the sample, and to do our probability calculation. And also then I repeat it 5 more times. So I repeat this a total of 6 times to calculate the probabilities for male and calculate the probabilities for female. So I hope this kind of makes sense. So now that we have our probabilities, again we are going to split our probabilities into different classes. Okay, and again, before we can split it by class, we need to turn it into an array, and that's very simple to do. So into an array, and let's just call it B for simplicity. Is equal to np dot array probability. So, and then split probability by class, and to do that is we just call it probability s is equal to np.vsplit, and we want to split B, and we want to split by number of classes. And let's do probability s and see what it looks like. Basically the same thing that we have here, but now it's split into 2 different classes. Now let's go ahead and calculate our prior. And prior is just our former prediction without any data. And it's simply like divide 1 by number of classes. So basically, like if we had 4 classes, our prior would be 0.25. If we had 10 classes, our prior would be 0.1, and stuff like that. So our prior is just what, like without having any data, what would our prediction be? And this makes perfect sense. Without having any data, we'll predict that's a 50% chance the sample that we're looking at is male, and there's a 50% chance the sample you're looking at is female. And now let's go ahead and do prior is equal to 1 divided by number of classes. And if we look at our prior says 0.5. All right, so now we are going to calculate our final probability. So if you remember in this equation, our final probability is calculated by taking the dot product of our probabilities and the prior. All right, so calculate final probability for male and female. All right, and to do that, we just create a an empty list. Final probe. Let's just go find equal to an empty list. All right, and then we are going to say for I and probability S. So basically, we're saying for each item in this list. So we have 2 arrays. The first array is male, second array is female. All right, so you're basically saying for each item in this array, class probability is equal to np.product. So basically, for you to get the product of something, you can just use numpy. Numpy has a product function. So, and then once I finish writing this code, I'm gonna explain it here in a little bit. You know what? I just do print. So basically, in this code right here, in this for loop, we are saying for each item in this list. So this is the first array and this is the second array. All right, and we are saying we want you to calculate the product of the first array and then calculate the product and then multiply that by the prior, and we know the prior is 0.5, and then calculate the product of the second array and then multiply that by the prior, which is 0.5, and we know the first array is male and the second array is female. Okay, and so basically that's what this line of code is doing right here. And then print probability. So this is the final probability for male and this is the final probability for female. And instead of printing it, I'm just going to assign it to a variable by appending it. So I'm just going to do final prob.append class probability. And now let's just do final prob so you can see it. So we just have a list. So this list right here, so this is the final probability for male and final probability for female. And we can look at the Wikipedia example and see. So 6.9 times 10 to the negative 9 and 5.3 times 10 to the negative 4 is exactly what we got. 6.9 to negative 9 and then 5.3 to negative 4. So we know our calculation is right because what we got here as the final probability is the same thing that they got in this example. So just remember, the first probability here is the male probability, second is the female probability. Now, how do we know? So now that we have our final probabilities, how do we know which sample this probability belongs to? Well, the bigger probability is one the sample belongs to. And to figure out the bigger probability is actually not very difficult. So we can do maximum maxi prob is equal to, we just use Python max final prob, and we can just do maxi prob and see what it looks like. And you can see right here 0.005 is bigger than this value, so based on final probability, we predict the sample belongs to female class. So if you remember earlier, I did np.unique. So basically here I'm gonna say classes is equal to np.unique. Why? So basically we are trying to see the unique items in classes, and I'm just gonna do classes here. As you can see, the first class is 0, the second class is 1. So basically saying we are using the index above to map out what our prediction is. So we are saying class that if you run this, it will give you 1. So basically, right, we are saying in this situation that the maximum probability is this, and this is located at index 1. And then we are trying to say, okay, so which class corresponds to this index, and then 1 corresponds to this index. So for example, this could have been index 0, for example, but let's say 2 was located at index 0. Then our prediction here will be 2. But overall, that's kind of like the basics of how to build a Gaussian naive based classifier from scratch. So our prediction came out to be 1, which is female, but we're also going to run this through sklearn just to make sure our Gaussian naive based classifier is correct. So this is the scikit-learn implementation of Gaussian naive bayes. So we can go ahead and import this. So from sklearn.naive bayes, import Gaussian naive bayes, and then I'm just gonna do this in one line. So skgmb is equal to, this is just me instantiating the class, and here we are going to do let's go ahead and pull our x values and y values. So basically I am going to pass in this x and y value into the scikit-learn library, and I'm also going to pass in this sample. I went ahead and added pd.series to sample because I think this is the format that scikit-learn expects its data. So let's go ahead and do our the fit and predict method from scikit-learn. So we do sk.fit, and then we say x values, and I need to run this code cell. X values, and then y, you just say y, and then let's go ahead and run this. And now let's do our predict method. Dot predict sample. So I went ahead and changed how I formatted the sample data because of how sklearn wants it. And when we run our sample data through scikit-learn, it also gives us 1 as a prediction. So the algorithm that we wrote gives us 1 as a prediction, and the scikit-learn library also gives us 1 as a prediction. That's pretty cool. This means that our algorithm is correct. So now I'm just gonna put all of this in a class. So all the code that I wrote above, I'm gonna take all of it and put it in a class. so that I could, let's say, call this class and do Gaussian naive based calculations. All right. So since I already wrote this code above, I'm not gonna spend time here like trying putting it in a class. You can read through this code, and again, this code will be found at free data science resources. In my free data science resources library. So if you go to machinelearnededucation.com/free, you can get access to this code and many other things I've written before. Or if you go to the blog for this, you can get access to it also. I have this class all the way at the bottom. Right here, I have the same class. And or if you go to the GitHub repo for this, so this one is actually on GitHub too. If you go to my GitHub repo for this, you'll be able to get access to this code, and you can look through it yourself and look through this class. And so basically this is me taking everything above and putting it in a class. And the reason why I put it in a class is just to make it easier for you and I to use it. So I went ahead and renamed our class Gaussian Naive Base just for clarification, because I have a function named GNB earlier in this code. So I'm just gonna run this, and then let's go ahead and test out our class that we just wrote using this, and we are going to use this as our sample data. And let's go ahead and instantiate our class, and then let's do g.fit, and let's use the x values above, and then let's use y. And now let's go ahead and run our class through our prediction method and just do g.predict, and let's type in sample 2. As you can see, our prediction comes out to be 1. So the class we just wrote gives us a prediction of 1, and also scikit-learn class also gives us a prediction of 1. So our class works. So that will basically do it for me. And of course, like I said earlier, you can check out the blog for this at evidencen.com/GNB classification. Yeah, go to evidencen.com/GNB classification to get the blog post for this. And you can join my free data science resources community here at machinelearnededucation.com/free. And also this code is going to be here, and any resource that I use in my blog or YouTube channel is going to be right here. And make sure to give this video a big thumbs up and subscribe. And if you think this video will help somebody else, please share this video with somebody else. Thank you so much. That's it for me. And that's basically how to build a Gaussian naive based classifier from scratch. Again, thank you for watching. Give this video a big thumbs up or a double thumbs down, and I'll talk to you on the next video. Bye.